Hey everybody, so this is going to be our last example using the rational root theorem with irrational zeros. So they want us to list all the rational zeros and then find all the solutions. So remember that we need to take the factors of 15 and divide it by the factors of the leading coefficient. Since this is 1, we don't really have to do that. We can just write out our factors of 15. So for the possible solutions, we can just say plus or minus 1, plus or minus 3, 5, and 15. So these are all possible solutions for this polynomial. Now what we need to do is take one of these and we're going to use synthetic substitution. That way we can determine if, or rather which one of these is going to be a factor of this polynomial. Now, you can avoid the whole guess check method simply by typing this in on your calculator. So we'll type this equation in. Now that I have my equation here, I'm going to hit second graph and I'm going to look at my table. So it seems that we're going to have a root here at -3. So since I know -3 is a solution, I'll evaluate there. And I'll use the leading coefficients from my polynomial for my synthetic substitution. So that'll be 1, -5, -29, and -15. Remember, the first term always comes down. So -3 times 1 is -3. Here you'll add. We'll multiply, we'll add, and then we will multiply one last time. So here, synthetic substitution, just confirming what the calculator told us, -3 is indeed going to be a solution because the remainder is 0. So the factor here, if -3 is a 0, then x plus 3 is going to be a factor. And then this factor will be the result of this answer here. So you have to remember that if I start with a 3, that this solution, leading degree being reduced by 1. So that's my x squared, my x, and my constant. So this is x squared minus 8x minus 5. So in order to solve, we have to set each of these equal to 0. So here I have x plus 3 equals 0, and I have x squared minus 8x minus 5 being set equal to 0. The issue here with this trinomial is that it's not factorable. There are no two numbers you can multiply together to get -5, and when I combine them, I get -8. So factoring is off the table. But what we do know is that the quadratic formula will find the solutions for any quadratic. So that's what I'll need to do here. So I have -b, so that's negative times -8, plus or minus the square root of b squared. So this is -8 squared minus 4 times a times c. And this will all be over 2a. So here I'm getting +8 plus or minus, this is 64. And it looks like I have -4 times 1, which is -4, and then -4 times -5 is +20. So 64 plus 20 is going to give me 84. And then my denominator is going to remain the same with 2. So you could write your solutions using this. I could say x equals -3, and it equals 8 plus or minus the square root of 84 all over 2. Now, remember that this solution here, it's really going to depend on your professor or your teacher. If they want you to simplify the radical, you'll have to do that, and then you'll have to see if your constants can simplify. The reason I don't do that is because this is the same number as that simplified solution. There's really no reason to simplify. It's only preference. Numerically, they are equivalent. So that's why I'll leave it here.